Good evening. What is up, everyone out there? I hope you're having a great night. I've actually teamed up with Tyler to help him out with this new B2B AWS learning path, where we're hacking real live AWS web services. Of course, everything within the boundary of the law. So with that, let's dive in. This room is called AWS IAM Enumeration. So I'm going to read this to you like story time style because I realize not everyone has access to this. And so just as a way to pay it forward to the community, we're going to walk you through this whole thing so you don't miss a beat. You may not get the hands-on, but you'll certainly get the content. And this is all with permission from TryHackMe. So they've been gracious enough to share this. Okay, so introduction to IAM enumeration. Prerequisites. Before starting this room, it is beneficial to have an introductory knowledge of identity and access management in AWS and should understand how to assume role trust policy works. If you're unfamiliar with this topic, please visit the AWS IAM room for more information. Learning objectives, knowing how to get information about AWS IAM resources without authenticating is an important skill for vulnerability assessments and penetration testing. In this room, you'll learn how to perform IAM principal enumeration and partial service enumeration for AWS environments. You will learn how IAM resource policies can be abused to identify valid IAM principles, how to use open source tools to effectively enumerate valid principles in a given AWS account, how to footprint potential services, including security services, enabled for an account. Remember, these IAM principles form the backbone of access in AWS. Without them, there is almost nothing you can do. By being able to identify what valid principles exist in another AWS account, you form a basis of information to perform more well-informed attacks that are more likely to succeed. It is possible to get information about IAM principles from a target account and other insider information about an account while remaining unauthenticated to that account. Interesting. This is referred to as an unauthenticated IAM enumeration. IAM enumeration is a reconnaissance exercise that can be leveraged to attack an AWS cloud environment. And by using this technique, an attacker can gain a better understanding of the IAM landscape within an account without having access to it. AWS pen testers and red teamers commonly use this gathered insider knowledge to gain information about resources residing within an AWS environment in order to perform attacks against the target account. Answer the questions below. Can you get information about an AWS account, including its IAM principles, without authenticating? I'd say that's a hard yes. Okay, moving on to assessing the environment. And this is just a general guide. To set up the room, we would generate the environment. And of course, we have credentials. So we won't go into this for the privacy information on this particular account, but this just is a general reminder. You would hit generate the environment, wait a few minutes, and you'd be all set. Okay. AWS IAM enumeration mechanics, scavenging for credentials or enumeration. You may find yourself on a machine and think, hey, I wonder if there is any AWS loot on here. Let's take a look at how you might enumerate AWS principles and credentials in use on a machine you've compromised. AWS Boto3, which is Python SDK, is one of the most mature tools out there for working with AWS APIs. Therefore, we look to Boto3 documentation to see how Boto3 looks for credentials when running AWS commands to learn where credentials might be stored. So reading through the docs, a few places stand out. Environment variables, users can get credentials using AWS Access Key ID. And we know that's one we want to guard and keep private. And AWS Secret Access Key obviously is the one that's paired with that. As as environmental variables. That's sort of your key to the kingdom right there. Shared credentials file, which is located in your home.aws credentials. If you have the AWS CLI already installed, you'll find them there. This is the most common place when storing IAM user access key or single sign-on configurations for assuming roles. AWS config file, which again is back to that home directory. Credential sources that reference helper scripts and other external credential providers are commonly referenced here. So this is in that config portion. So you've got the credentials and the config that are both in that .aws folder. Assume role provider. The trick here is to know that when someone uses AWS single sign-on or another mechanism to assume a role via the AWS CLI, that the AWS CLI tool caches credentials for each role session at home directory.aws/CLI/cache, and then of course your role session ID. Botto2 config file is another place. Botto2 is the predecessor version to Botto3. Some people are still on Botto2, and it might be used for legacy clients and environments. Instant metadata service, IMDS, on an Amazon EC2 instance that has an IAM role configured. Okay, so those are the hotspots. While Botto3 checks for credentials stored at the metadata endpoint, AWS Elastic Container Service, ECS, tests also have a metadata endpoint, which is here. I don't know if you recognize this, but it's pretty common knowledge. It's in the docs. AWS Lambda store credentials as environment variables, and Cloud Shell stores credentials via a local host metadata endpoint. If you find yourself on a compromised system, any of these are potential sources of temporary credentials with varying levels of privilege. Let's get started by logging into the AWS Cloud Shell or our attack box with our AWS credentials. So I've already done that. We're already logged in, which we can confirm. Just as a reminder, this is sort of our who am I of the AWS world. Get caller identity, and gotta have a profile, which if I've set this up correctly, this should fire back. Yeah, so now it's tied to this account. Okay. And it just, yeah, we just did that. Running this command should return the AWS account to which the access key belongs. Interestingly enough, you can perform this command unauthenticated, meaning that you have implicit permissions to access this API by default in AWS. This can help provide important context regarding the account you've compromised in conjunction with the account alias, along with IAM and other resource naming tagging conventions. Go ahead and try it with your access key ID, which we did. And then we have resource-based policies, as we discussed in the AWS basics room. AWS resource-based policies are IAM policies applied directly to certain types of AWS resources. Interestingly enough, these resource-based policies have a little quirk that allows attackers to identify any valid IAM principal in a given AWS account, and even the validity of any particular AWS account ID. Resource-based policies are comprised of the following format. And there you just have an example. When attempting to enumerate an IAM principal via resource policy, you simply create the resource that supports a resource-based policy and then update it to allow access for the principal you want to test whether it exists. If the principal does not exist, the update command will return an error message. If the principal does exist, then you will not receive an error message, and the updated resource policy will be implemented. For most types of resource-based policies, this consists of account IDs, IAM roles, IAM users, and IAM users. Other types of principals aren't enumerable using this method. Okay, so all that's great background. It sounds like we could do this manually, but the tools do this for us by and large. So if an IAM principal does not exist, what does an attempt to update the resource-based policy to include wow, the principal return? And I would say it returns an error message, right? Okay. Hey, the streak's going. Okay. And check it in. Okay. We're good. So enumerating IAM users and roles. Ooh, we get to play with a tool. In order to perform enumeration, we'll be using a tool called Quiet Riot. Yay! Quiet Riot can be used for unauthenticated enumeration of AWS Azure Active Directory, Google Workspace, users, principals. The reason I use quotes around unauthenticated is because even though you don't have to be authenticated against the target you intend on scanning, for Quiet Riot to work, you do need to be authenticated to an account with permissions to deploy resources that Quiet Riot will use. Excuse me. In its scanning, you can view the source code for Quiet Riot on GitHub. Okay. If you are using the attack box to work the rooms, then you are already familiar with using the AWS CLI tool and using AWS Configure to configure credentials. If you've been using Cloud Shell, this may be your first time loading credentials. Because Cloud Shell relies on the AWS metadata service to retrieve and use credentials, you won't find any credentials configured in AWS Cloud Shell if you try to navigate to your home directory here when you start up. And this might be a problem when using tools that default to using the default credential profile commonly implemented with AWS CLI. So just keep that in mind. Once you have credentials configured, which we do, if using Cloud Shell, you will want to install Quiet Riot. Hey there, Black Cyan. You can also do so by running the following command. Okay, so it's as easy as pip3 install Quiet Riot, which we've already done. And we can test that Quiet Riot is properly installed by running the following command. So God, I kind of like the name of this tool. So there it is, right? And we should just get an output. Oh, we should have gone tac help, but we got there. So yeah, we're good. We're locked and loaded. Now you'll want to use Quiet Riot to scan your target account for potential users and roles. During S3 and API gateway rooms, you will note that Best Cloud Company, that's our target, appears to employ two individuals by the names of Adam and John. Assuming Adam and John are technology employees with access to AWS, we could attempt to look for their users by creating a word list of potential usernames using common patterns employed by companies and common family names in the USA, where Best Cloud Company appears to be based. Assuming you have the family names file stored in your local directory as file names USA Top 1000, in your local directory, you could use something like this, following script to generate a list of common Adam and John users names. So this is just a simple Python script that will, looks like, convert everything to lower and go through the various permutations of first and last name. You can try the script for yourself, but I've also included the pre-generated list, nice, of common users names using the names Adam and John. So you might use them for yourself with Quiet Riot. Once you have the usernames, save them as usernames.txt in your machine of choice. Then we can use Quiet Riot to test them out. So I believe I've done that. Yeah, I've got the usernames. So here's our first command with Quiet Riot. So with a scan 5, that's just an option, a menu option. And we'll get 2 choices. We can go after roles or users. So we're going to go after, looks like, roles first. And our account, which right there. So we have to have a valid account to scan against. That's the requirement. And there's our word list. Okay, so the scanning is in progress. See if we get any hits. Now that you've provided your word list, we will press enter and wait for the scan to conclude. You can expect a scan with this many options to take between 3 and 10 minutes, depending on a variety of factors, including network latency and potential API throttling by AWS. And that throttling is a real thing. Hopefully they'll leave us alone tonight and let us scan quickly. Identified valid principles. So far, nothing. And what I notice is that the more you do, the more noise you're making, the more throttling and other slowdowns that you're going to encounter. So just be mindful of that, because we are attacking the real deal here. This is a real account. This is AWS real infrastructure live on the public internet. So this is about as real as it gets. But just to underscore, this has all been set up by TryHackMe, and we are within the permissive bounds of the law. So we might be under a slight throttle here. I'm going to check chat here while we're waiting and see how everyone's doing out there. Okay, everyone's happy in Hackerland. Good. I'm happy too. Well, let's continue reading and hope for the best here on this scan. As you can see, we weren't successful. Yeah, we're not even finished yet in identifying any roles with the scan. Number of identified valid principles is 0, which, we're not even done yet. Maybe best cloud company implements IAM users instead. Try it for yourself. After running the Quiet Riot scan a second time, with scan type 2 selected, did it identify any IAM users? Well, I think we could safely abort this. And you can do it. Come on, Python, please. Boy, there we go. Okay, so let's do this again, but we'll go after that second option, menu option. Okay, and we need our account. There we go. And usernames. Okay, hopefully this one goes a little smoother. I do notice a slowdown, so it's either all the stuff I've going on at once or it's AWS throttling us. So we have 2 questions to answer after this scan, which is what is John's username? and then what is Adam's last name. So I expect this scan to get some hits. Boy, our scans are just a lot slower than normal, which means I've been on AWS too long. I've actually finished this entire course. So I'm actually working my way backwards because Tyler's doing a bunch of videos from the beginning. So I figure we'll just kind of meet somewhere in the middle. And that way we won't overlap or get anything too out of sequence, so that you'll have at the very end, you'll have this entire sequence that you can refer back to and get the content. But for some reason, my scans are just not working, which is a shame, right? Stuff happens live. We might just have to hit the I believe button. I'm going to give it, we'll move on and hope for the best here. And if not, I've got another way to get this. Okay, so task 5, enumerating root user email addresses. We mentioned earlier in this room that resource-based policies could only return IAM users, IAM roles, and AWS account IDs. Well, that isn't completely true. There is one exception. When using legacy AWS S3 ACLs, access control lists now deprecated by default, you can use the ACL policy to place email addresses that correspond to potential root user email addresses. Now that's interesting. These root users are particularly interesting as an attacker because they have full permissions against the AWS account, unless otherwise restricted by AWS Service Control Policy, SCPs. As an attacker, if you take over a root user account, you have the proverbial keys to the kingdom. Yeah, just like anywhere, right? Quiet Riot supports scanning for root user email addresses, though this technique is inherently slower because it is only supported by the S3 service and is prone to rate limiting. Let's try Adam and John's IAM usernames as potential root users. We found them as regular IAM users in the last task after all. Okay, and that, I guess we're hitting the believe button because my scan, I don't know what's going on. We'll create a new file called rootuser.txt and add each potential email username to a new line. Then run Quiet Riot with the S option. Well, Quiet Riot, why are you not behaving? I'm gonna close this out just in case. And we're going to fire you up again, because I believe in you, Quiet Riot. And we're going to do that one more time, because if it's working, it works really fast. And this is already not a good sign because it's so sluggish. So this just might be my system. But we're going to give it one more shot here. And usernames. Come on, I believe in you, Quiet Riot. Note to self, reboot before you fire all this up, because I probably had a lot of resources and memory leaks that were just because I've been using this a lot this whole week, and I haven't rebooted. So, note to self: always start fresh, because that might be what's going on here. We're just running low on resources. So we're gonna have to hit the I believe button, because these scans are just, I have a feeling, are just not gonna finish. Like I'm even looking at how slow, even just to there we go. So okay, so what I did here though is, and what they're asking us to do is create this file with the 2 usernames, which we would have gotten from the previous scan. Okay, so unfortunately we got to hit the I believe. Sorry, I couldn't demonstrate that for you live. Let's see though if we can do this next scan, because this next scan is pretty quick, because we only have 2 usernames. Come on, QuiRide. Okay, and we're gonna pick option G for custom username list, because we have a custom root user.text. Domain name is best cloud company. Just going right off the notes here. And come on, QuiRide, you can do this. Oh, look at that. Okay. So now what it's telling us says it looks like neither Adam or John are administrators. Okay, we didn't get any hits. Unfortunately, due to the sensitivity of AWS root user email addresses, we aren't going to be providing a valid email address for this room, and I think you can see why, right? We just can't hand out root access on a live AWS account, right? However, QuiRide supports validating email users in Office 365 and the G Suite, the 2 most common enterprise email providers. That means you can create potential user lists, validate the emails against Microsoft or Google tenants, and then run large lists of valid emails against AWS for root user email validation. You might be surprised by what you can find. So the answer to the question is, what type of S3 policy allows you to enumerate root user email addresses? So if we just go up here, I believe it said us in the first paragraph. Yeah, I believe it's ACLs, right? You can use ACL policy to place email addresses that correspond to root user email addresses. So I believe that is ACL. Okay. The final task is footprinting AWS services in use. The last concept we're going to cover for IAM enumeration is a little different than identifying potential principals to attack or take over. That is because it isn't just humans that utilize IAM rules. No, the AWS services also take advantage of the AWS IAM role concept in order to perform automation on your organization's behalf. In fact, if you have a service configured to do anything automatically on your behalf in AWS, odds are someone, or automation ran by someone, enabled an AWS service role. Okay, interesting. AWS service role that is being used to perform the actions on the service's behalf. You see, even AWS services need permissions to perform actions in your account. It isn't uncommon to see an IAM assume role trust policy with a similar structure to the following. Okay, so you've got principal, service, lambda, dot. Okay, so this is sort of the syntax here. Lambda.amazonaws.com, and I assume the lambda would be the service. This demonstrates that a particular AWS service has the ability to assume the role defined. In this case, the AWS Lambda service, there we go, can assume the role with whatever permissions are applied. It turns out this can be really useful when trying to do reconnaissance against an organization. See, AWS uses predefined AWS service roles, names that can be used to identify common services and notably security services such as guard duty. If you know a particular account you want to check enabled services against, you can run the following quiet riot command. Okay, so here we go. I believe in you, Quiet Riot. You can handle this one. So we do a double tag S3 scan. And I'm guessing we're going to need that account number again. Wow. Okay. I guess that's all it needs. You can do it. So it says, what services do you see enabled in the account? How might it change your actions regarding an access key you might find? With guard duty in particular, you know that there are specific security alerts that may be triggered by actions in the account. One special note is that these accounts may continue to be registered in an account even if an organization discontinues its use. Therefore, it's important to understand that a role's existence isn't 100% accurate regarding the current service use. So, okay, so we were trying to figure out John's username. And Adam's last name. So, the way we can do that is run the scan just like they talked about with option 2 for users. And the account going usernames. There we go. See, I didn't do anything different other than start over a fresh system. So yeah, we had some bugs. So now we've got John Cervantes as the first user. Okay. And just waiting on Adam. Can start quiet on another thread. Well, let us. I guess we're going to find out. Hey, you betcha. Oops. Need that account number. Over here. Here we go. Hey, there's our services. Yay. Okay. And look, so we have our 2 usernames. Adam's last name is Foreman. Go back to that guy. Thank you, Quiet Riot. And so as far as how many roles does Quiet identify in your account? So that is this other thread. So I don't think this one counts because it doesn't have this .amazon AWS.com naming convention. So we got 1, 2, 3, 4, and 5. And then what does the hint say? All lowercase, use the service listed before the .amazon AWS.com and sort alphabetically. Okay, so we're going to go alphabetically. Guard duty would come first, G, right? And then O, organization. There we go. And then support. And looks like T comes after S, right? Alphabetically. And okay. And so how many do we have here? We've got 1, 2, 3, 4, 5. Okay. And there we go. So I hope you learned something today, and we'll catch you on the next one. Happy hacking.